Okay, so I'm asked to differentiate this function. So this is the outer and this is the inner. So when I differentiate the outer, I get cosine e to the x multiplied by the inner function. I would have stopped here if this were x, but this is e to the x, but e to the x prime is e to the x. Plus e to u prime is e to u times u prime. I would have stopped at e to x to the x prime as e to the x. But if this is a function, I have to multiply by that function prime. And that's it. So the only other thing I would have done is just put e to the x in front. Plus e to sine x times cosine x. Okay? That clear? Yes? Okay. So let's go back now to and try to finish up implicit differentiation. One more time, other questions for me? Anything else? Anything else that you would like to see? Anything else? Okay. Last time, and maybe I should go back here. So last time we looked at some problems that you had questions on, then the quiz, and then I said, please mark down your calendars Wednesday the 25th, 2 weeks from today, for test 2. And then we proved sine prime to be cosine prime, sine prime to be cosine, and then the rest we just use the quotient rule to determine them. Just use something that you pick, not everything. And then we looked at the chain rule, and we said chain rule alone is one thing, and chain rule combined with the power rule is a different thing. And then we differentiated different functions that could not be differentiated without the chain rule. And then more, and then simplified. And I said this is one notation that we will be using. Actually, both of them will interchangeably. So it's good to know. So then we looked at a problem in which we apply the chain rule and not apply the chain rule from the beginning. I mean, I shouldn't say that. In which we apply the chain rule without plugging in the function in the other one, and then the same thing with plugging in the function. So here it is, e to u prime is e to u times u prime. And then we started the implicit differentiation, but I only showed an example that I made up on the spot. So we didn't look through the handout. So now let's do just that. Ready? So in some situations, we may be asked to find solve for y first, and then just determine, sorry. Okay, sorry about that. So in this particular case, for example, I am able to solve for y. It's the cube root of cotangent x plus 4x to the second power. Even here I can solve for y. Even here I can solve for y. Here I cannot. Here I cannot. Here, obviously, I cannot. So in certain situations, you may be asked to solve for y and then find dy over dx. In other situations, you will not be able to, so you will have to find the derivative implicitly because you cannot find the function. So now, please choose. I don't know if we really need to do all three, but I'd like you to choose whatever you want. Or we can choose from your text. It's up to you. Any preference? B? Yes. Okay, very good. So you want to solve, or you just want to use implicit differentiation? Say it again. Yes. So if we want to solve for y, so the question here is dy over dx. When I'm asked to find dy over dx, I am really told two things. Number one is that y is a function of x, which means y is the function, in other words, and x is the independent variable. The second thing that I'm asked to do, or I get the information from, is that I'm asked to find an equation, if possible, that represents, or a function, hopefully, that represents the rate of change of y with respect to x. So if you want to solve for y, then you will have to solve for y cubed first. X to 2/3 divided by 3x cubed minus 2x plus 1. And taking the cube root from both sides makes it very messy. Not a trivial problem. So the cube root of x to 2/3 over 3x to the third minus 2x plus 1. This is ugly, but let's do it. So I will have to rewrite it as x to 2/3 divided by 3x cubed minus 2x plus 1. And now I will differentiate. So this is a function raised to power 1/3. So I have to bring 1/3 in front. I have to subtract 1 from the power. And now I have to multiply this by this prime. So since I don't have room here, I'm going to say the inner function prime. So now I will continue and write it again. Maybe it's easier for everyone to see. So I'm going to copy this. I'm going to flip the 2 so I can change the exponent into positive. So 3x cubed minus 2x plus 1 over x to 2/3 raised to 2/3 this time, times the inner function prime, which, as I said, is awful. I have to differentiate the function at the top, which is 2/3 x to negative 1/3. And since it's x, I don't use the chain rule. Multiply by the denominator, which is 3x cubed minus 2x plus 1, minus. I copy the top and multiply by the denominator prime, which is 9x squared minus 2. Over 3x cubed minus 2x plus 1 squared. Yes, we can further simplify this only by factoring x to negative 1/3. There's nothing else I can do. I could possibly simplify a little bit with the numerator, but it's going to be cumbersome. It's not going to be an easy situation. So let's try and continue it. So I have 1/3 in front. Then I have 3x to the third minus 2x plus 1 raised to 2/3 over x to 4 over 9, copy the base, multiply the exponents, 4 over 9, times, from here I'm going to factor out x to negative 1/3, I meant to say. So this is 2/3 times this. So 2x cubed minus 4/3 x plus 2/3. And here, when I factor out x to negative 1/3, 2/3 minus 1/3 is 1. So then I have plus 9x cubed minus 2x. Horrible. Absolutely horrible. Over 3x cubed minus 2x plus 1 to the second power. So what I can do here, okay, I will simplify these two, or I will actually bring it down. So I have 4 over 9 plus 1 over 3. So it's 7 over 9. X to 7 over 9. Then I keep this, which I should simplify. So I can bring, so 2 minus 2/3. 2 minus 2/3 is 6. Minus 2 4/3. So I bring this down to 3x to the third minus 2x plus 1 to 4/3. So these are together here. These are together here. I have a 3 in front from 1/3, and whatever that is, 11x to the third. 3 times 2 is 6 minus 10/3 x and plus 2/3. One more step, find the least common denominator. This is, as I said, awful. X to the third minus 10x plus 2. But this shows when we look at the other way and compare, we'll see what we can conclude. It took me 2 pages just to simplify this and find the derivative. So this is final. Let's see what we get with the other option. Not differentiate, not solving. Where is my problem? So I have x to 2/3 equals y to the third. 3x to the third minus 2x plus 1. So by not solving, I may be able to get a nicer form. We'll see in a minute. So when I differentiate this side, I differentiate this side. The left-hand side is 2/3, x to negative 1/3. But the right-hand side is a product, and I have to be very careful. I differentiate 3y squared dy over dx times the second function, 3x cubed minus 2x plus 1, and plus y to the third, and now I differentiate this, which is 9x squared minus 2. So all I have to do is just move this to the other side. So I have 2/3 x to negative 1/3 minus y cubed 9x squared minus 2 equals 3y squared 3x cubed minus 2x plus 1 dy over dx. All I have to do is just solve for dy over dx, which was much easier. So I was able to finish this in 2 steps, maybe 3 if you want. But here it took me like forever. First of all, to use the quotient rule. Then to simplify. And you can say, but they don't look the same. Oh, you're right, because here I have a function y. So what I have to do, they will look the same, but after I replace this by this. So when I replace y cubed by this, put it in here, and y squared by this to 2/3, then they will look the same. But the question is, which one was easier? Well, obviously, this is step 1, step 2, and step 3 when I divided. So this was a much easier method, not solving for y, but going ahead with implicit differentiation. Any questions on this? Okay. Use implicit differentiation to find the derivative. So let's look at these problems. Would you like to work on another problem from here, either A or B, or we move on to this set?
We do,
Yes?
we do C.
Yes, of course. So we have 4x squared plus 9y squared equals 36. Which way? Would you like to use implicit differentiation, or would you like to solve first?
Implicit.
Implicit. Very good. So for implicit differentiation, all I have to do is say that I differentiate the left-hand side and I differentiate the right-hand side. So how do I write the left-hand side? Can anyone tell us what to do? So 8x plus, yes, 18y times, y is not a variable, y is a function, times what? So how do I differentiate a function to a power? I bring down the power, I subtract 1 from the power times what?
F prime.
Exactly. So I'm missing f prime. I have the constant, I have 2 minus 1, but I don't have the function prime. So what am I missing here?
Y.
I brought down 2, I multiplied by 9, I got 18. 2 minus 1 is 1 times. I have this, I have this. I'm missing this piece, I don't have it here. So what do I write? What did we write before? How did I differentiate y cubed before as a function? What did I write? 3. I subtracted 1 from the power times the inner function prime. How do I write the inner function prime? Can anyone read this for us? Can anyone read this for us? I refuse to believe that no one can read this for us. What is this? Right, dy over dx. 2 times dy over dx. So the constant is 2 multiplied by 18. 2 minus 1 is the function times the inner function prime, which is dy over dx. Equals how much? 36 prime. What is the rate of change of 36? 0. So then I move 8x to the other side. I'm solving for dy over dx. So 18y dy over dx equals negative 8x. So dy over dx equals negative 8x over 18y. And of course, I'll simplify by 2. So dy over dx will be negative 4x over 9y. So what was the problem a minute ago? What wasn't clear? I'd like to go back and address that. What was the question or the unclear situation?
Why we have to multiply d times dy over dx.
I'm asked to find dy over dx, which means two things. Y is a function of x. I cannot differentiate y the way I differentiate x. X is the independent variable, y is the function. So when I say here 8x, I should write times x prime, but x prime is 1. But this is a function that I don't have. So 9y squared prime is 18y times dy over dx. I have to use this chain rule combined with the power rule. So a function raised to a power is the power times the function to the power minus 1 times the inner function prime.
Okay.
Is that better?
Yes.
So I have to use this on y. I will not use it on x. Even if I do, times x prime will be 1. So in the same way, we differentiated here. So nobody asked me here. So maybe you are not following.
I have my hand up.
Okay, let's repeat this. So y cubed prime, y is a function of x, is 3y squared times the inner function prime. So in the same way here, 9y squared is 18 times y times the inner function prime. Is that better? Okay, perfect. That's why we need to practice. it takes time. So now let's move on to the next set. Please choose. Maybe you should work on one of them for a minute. Please choose one and let's work on it. Which one we would like to work on? A. So we have x cubed minus y squared equals 6xy plus y. So let's work on this for 1 minute. You cannot solve, don't even try to solve for y. If you need my help, please raise your hand. I'll come over. Can anyone just put us on the right track? What we are trying to do? So how do I start this? Just
take the derivative of both sides.
very good.
So x.
Right, which means I'm asked to find dy over dx, which means x will be treated as a variable, but y will be treated as a function. Good. So let's work on it for 1 minute. Can anyone dictate the left-hand side if you have it? Very good. 3x squared indeed. Minus 2y. Excellent. dy over dx is the left-hand side. Perfect. Now I have to be very careful with the right-hand side. Why? Because this is a what? Exactly. Be very careful. So we have to employ the product rule. Okay, let's work on the right-hand side. When you're finished with the right-hand side, let me know. So here's what I would do with this product. I would leave 6 alone. It's a constant in front of a function or a product of functions. It doesn't matter. The first function prime is 1 times the second one plus the first function times the second function prime. I don't have the function, so I have to write dy over dx. And then finally plus what? Exactly. So now let's distribute. Of course, if you use a different method, I'm fine. If you use mine, then you have to distribute y, and then what are you going to do? What is the variable here? What am I trying to solve for? Am I solving for x? Am I solving for y? Am I... Exactly. This is what I'm solving for. So you have to bring all terms with dy over dx on one side and everything else on the other. So let's do that. That's our next step. So what I have is 3x squared minus 2y dy over dx equals 6y plus 6x dy over dx plus dy over dx. All these terms have to be on one side. So I'm going to move this one here and this one here. So 3x squared minus 6y equals 2y plus 6x plus 1. I already factored dy over dx because this is the only way. I have to factor out dy over dx. I can combine like terms. I cannot combine 2y dy over dx to 6x dy over dx and plus 1 dy over dx. So I have to factor out dy over dx. And then I reach the final stage. What is the final stage? What do I have to write as dy over dx? What will that equal to? The top will be 3x squared minus 6y. Very good. And the denominator will be plus 6x plus 1. Exactly. We need to work at least on one or two more. At least. How do you feel about this one after this problem? Okay, so let's choose. Okay, let's do C. Any questions on the previous problem? Anyone? Feeling somewhat better? A little bit? Okay, so in C we have cosine of the square root of xy equals y. Careful with this side because we have an outer function which is cosine. We have an inner function that is the square root and a further inner function that is a product. So I have to rearrange it as cosine xy raised to which power? Very good. Equals y. So this is how we start differentiating. So let's think about it for a minute. So remember, this differentiated, then this differentiated, and then this differentiated. So it's the chain rule. You will have a product with three factors. Let me know if you need help, please. Can anyone get us started on the left-hand side? What do I have to write first? What is the derivative of cosine?
Negative sign.
Very good. Negative sine of xy raised to 1/2 times.
1/2 xy.
1/2 the square root of xy. So let's stop here for a moment. I didn't finish, so I'm going right here. So if I have the square root of a function prime, then I have 1/2 the square root of the function times the function prime. So I have this to 1/2 prime. So it's 1/2 times this. This is the function, right? And now times the inner function prime. Since it's a product, I have to have a sum. First function prime times the second one plus the first times the second function prime. And this is just the left-hand side. Quite hairy, right? Complicated. So let's do this together one more time. This is the outer this is the second, and this is the third. When I differentiate cosine of this, I get negative sign. But now I have to differentiate the square root. So it's 1 over 2 the square root times the inner function prime, which is this prime. So the first function prime times the second plus the first times the second prime equals. What do I have on the right-hand side? Excellent. Indeed. So now, look what happens. This is a factor, right? This has to be distributed to y, and this has to be distributed to the second term. And then I have to move the terms with dy over dx to one side, okay? So again, I'm going to put this in one fraction. I'm going to put this up because it's over 1. So I'll multiply these two and these two. So I will write negative in front. Sine of the square root of xy over 2 the square root of xy times y. Then minus sine the square root of xy over 2 the square root of xy times x dy over dx equals dy over dx. So let's look again. I changed this into a fraction because it was a lot of writing. So this multiplied by y, it's the fraction multiplied by y, and then this multiplied by x dy over dx, minus this, the same thing, by x dy over dx. So now I notice that the variable I'm after is in this and in this. So this term will go to the other side. The left-hand side stays as negative. I'm going to put y in front. Negative y sine the square root of xy over 2 the square root of xy equals something with dy over dx. I'm going to already factor it out. So it will be x sine the square root of xy over 2 the square root of xy and plus 1. Because when I bring this to the other side, this factor is here, positive now, and plus 1, plus 1. And then finally I have dy over dx. Can anyone dictate dy over dx? What do we have at the top? What do we have in the numerator? Yes, Tony?
Where
Go.
did that extra x come from?
This one?
Yeah.
It was in the problem. See, this is a product. When I differentiate the product, I have the first function prime, which is 1, times the second one, plus the first function times the second function prime.
I would drop it for some reason right now.
That's okay. So now how do I find dy over dx? What do I have to do? What do I have in the numerator? I'm solving for this, and this is a constant that multiplies it, so this must go to the denominator. So what do I have at the top? Must be this. So negative y sine the square root of xy over 2 the square root of xy over x sine the square root of xy over 2 the square root of xy plus 1. I will find the least common denominator because I see they are the same and get rid of the denominator. So finally I have dy over dx equals negative y sine the square root of xy over x sine the square root of xy plus 2 the square root of xy. And we cannot further simplify this. This is it. Any questions? Any questions? I know we have a couple more problems there on the handout, but I like you to choose from these problems from 5 through 32, at least one more to work on together. So on page 2 to 15, from 5 through 32. Please choose one more to find dy over dx implicitly. Any problem that catches your eye. And then I will talk a little bit about, we're going to look at the other two problems that we have here. And then I'm going to refresh your memory on a little bit about inverse trig functions. And I'm going to present their derivatives. 19. 19. Yes. E to the y times cosine x equals 1 plus sine xy. Let's work on this for 1 minute. Let me know if you need help. So e to y times cosine x equals 1 plus sine xy. Let me know if you need help, please. When you're ready to with the left-hand side, please tell me what it is. Do we have the left-hand side? Anyone? Do we? Yes. Very good. Times. Very good. Plus. I know we will change into minus, but let's write plus first. Very good. Times. Very good. Excellent. Do we all agree with the left-hand side? Everyone? Okay. Now the right-hand side, please. So yes, I should have written this for everyone to see. So now the right-hand side, please. Very good. Times. Excellent. Wonderful. Well done. Very good. I appreciate it. So now I have to clean it up. I have to distribute this to these two terms. Separate the terms with dy over dx. So I'm going to put cosine next to e to the y. So e to y times cosine x dy over dx minus e to y times sine x equals y cosine xy plus x cosine xy dy over dx. So I copied this, I just rearranged it a little bit. I copied this without parentheses. I distributed this to y, and I distributed this to x. So now I know I am after this. They must be on the same side. I'm going to take this term here, and I'm going to take this term to the other side. So I have, and I will factor out dy over dx. E to y cosine x minus x cosine xy. And I factor out dy over dx equals e, what is this? What did I do here? Oh, sorry. There's no need for that half parenthesis. Sorry about that. Okay, so e2, where am I? E to the y sine x plus y cosine xy. Is this clear? So I took this term here and I factored out dy over dx. So I had e to y cosine x, but minus x cosine xy. And dy over dx factored out. I move this term to the other side, which I have here now, positive, plus y cosine xy. Is this okay? Okay, so now final step. Final step for writing dy over dx. Can anyone dictate dy over dx now? Now after this example, do you feel a little bit better about implicit differentiation? Do you think we need another example? If you say yes, we'll look at another example. I don't mind at all. So can anyone give us the final form for dy over dx? Yes. E to y sine x plus y cosine xy over do not fall into the trap of trying to simplify anything. There is nothing. You cannot simplify in a sum or difference. These are not factors. So this is it. Okay. Do you feel better? Will you practice and then ask more questions, or you want to work on one more right now? It's up to you. We need another, or can we move on? Well, actually, we have two more problems here, so maybe that will find the slope of the tangent line to x squared y cubed equals 8. X squared y cubed equals 8 at 1, 2. Find the slope, just the slope, of the tangent line to x squared y cubed at equals 8 at 1, 2. So now the question is this point on this curve? How do I know whether this point is on this curve? And you can say, well, it's given to me. I'm told to find the slope of the tangent line to the curve at that point. True, but I'm asking you, how do I know that this point is on the curve? What has to happen for a point to be on the curve? What if 1, 2 is not on the curve? How do I check whether it is or it is not? Plug it in, of course. So 1 squared times 2 cubed is that 8. So it's guaranteed that 1, 2 is on the curve. Good, perfect. So how do I determine the slope of the tangent line to the curve given here at point 1, 2? What do I have to find? Of course, how do I find the slope? What do I have to find first before I get the slope? Yes, of course. Good. So can anyone dictate the left-hand side? The left-hand side equals? Anyone? 2x? I can't. That's not how I differentiate the product. Two x. Yes, I agree with that. Plus, I agree with that. Very good. Equals? Excellent. I have to solve for dy over dx. I only have to move this term to the other side. So I have 3x squared y squared dy over dx equals negative 2xy cubed. So now I want dy over dx. What do I have to write? What does dy over dx equal to? What is at the top?
-2xy.
Excellent. Y cubed. Good. And the denominator?
3x cubed.
3x squared y squared. Yes, I will simplify. I will remove an x from the top and an x from the bottom. I will remove 2 y's from the bottom and 2 y's from the top. So the final simplified form of dy over dx is negative in front. What do I have left at the top? Numerator? 2y indeed over 3x. Perfect. Excellent. Now I am told to evaluate this, and here's how we like to write it. I can put 1 comma 2, or I can write x equals 1, y equals 2. That's the point that is given to us. So now, after I have an expression representing dy over dx, I can plug in whatever you give me. So then the top will be, so then the minus, the top will be 4, the bottom will be, that's it. So if you have any doubts, maybe we should write it. This is the slope of the tangent line, or the rate of change of the curve at that point, right? Same thing. So negative 4/3 is the slope of the tangent line to the curve at 1 comma 2. It's also the rate of change of the curve at that point. Very good. Okay, and the last one here. Are you feeling a little bit better about implicit differentiation? Okay, so we have the square root of a squared minus b squared equals 4ab. They want us to find dA over dB. What does that mean? When we're asked to find dA over dB, now you could say, but you just told us a and b are constants. Right. When I have x and a and b are constants. But when I only have a and b, and I'm asked to find dA over dB, then one is the independent and one is the dependent. So which one is the independent variable here?
A.
A is at the top. So A takes the place of y. Because I have this, if I had it reversed, I would have said B was at the top, so then B is the function. But since I have A at the top, I'm clearly told that A is the function and B is the variable. So A is a function of B. So we will differentiate both sides, keeping in mind that A takes the place of y and B takes the place of x. Okay, so let's do that and then we'll continue.